the only thing I knew about physicists was it was a job option on the Game of Life. And I remember being like, what's that?
Alright then, here we are for part 2 of the Zoom chats. Last time was Rob Powell, and this time we're going to be chatting to Emma Osborne, who has recently completed her PhD in astrophysics and is now working in a science communicatory role at the University of Bath. Emma explains her research. Okay, it was in astrophysics, it was all to do with neutron stars and coding on Python, very techie. But she breaks it down quite nicely and it sounds really cool. And then we talk about maths and, you know, its relevance to physics. But a really interesting thing is, okay, I like maths. I'm a maths teacher. My degree was maths. Emma had a bit of a shaky start with maths, but she managed to flip it around to the point of doing her PhD. She explains it much better than I just have, so I'm going to leave that to you. But we also talk about Emma's Instagram and a TikTok and a Twitter and a YouTube, so be sure to check those out. Yeah, this is a good one.
Here he is.
Oh, that's quite a big dog in my opinion. That's a nice dog.
Yeah, he's short, but he's hench.
What's he called?
Sunbathing. Rudy, because he's a little rude boy. He's like 5 now. I'm just going to kick him out. Hang on.
Alright, no problem.
Come on then. Oh, careful, mate. You good boy, get down. Out you go.
To get started, Emma, what I want to mention was your Instagram account.
Yeah.
Because like yesterday you mentioned to me in a video and I have never had so many followers in one day. It was unbelievable. What made you start your Instagram account?
So I actually started it to support my YouTube channel. So that started first, and I thought, you know, it's really good to have more than one social media channel. And I already had an Instagram account that I used for my friends and documented a bit of my undergraduate on, and then I just thought I'd make it a bit more physicsy. So that's kind of how it started.
I remember when you first told me about it. Do you remember when you told me?
That was at the Royal Society thing.
Was,
I think that's before my account grew. That's when I just started doing it. Yeah.
It really stuck in my mind that because we had been at the soiree, so I was there in a tuxedo. You were in like a gown. We're sat outside the Royal Society, and you're like, "Oh yeah, follow me on Instagram at Emma of Enigma." I was like, "All right, yeah." Followed it when I got home, and I was like, "Oh my god, how many followers? Like you're up to 47,000 now, yeah?"
Yeah. It was a bit higher, but it's ticked down because I completely neglected it during my PhD. So yeah, all the bots are dropping off, which is a good thing, really. So.
Well, it's understandable if you've been focusing on your PhD. So that's all done.
Yeah.
Then.
Yeah, completely finished, and I'm just waiting for the office to reopen so I can get some documents. But yeah, graduation's cancelled, so when it's availably official, I don't know. But that's pandemic life, isn't it?
Would you mind sharing what it was about?
Yeah, sure. It's about how neutron stars can produce gravitational waves by growing mountains. And so gravitational waves have been detected from 2 black holes that crash into each other and 2 neutron stars that have crashed into each other. But we haven't had one from just a single neutron star. And the reason behind that is because to make gravitational waves, you need some kind of like asymmetry. So it needs to be a bit wonky. So humans are really good at making gravitational waves, but neutron stars, they have a huge amount of gravitational attraction. So they're one of the roundest things in the universe. So it's really hard for them to make gravitational waves. But sometimes they have a neighboring star like our sun, and the gravitational field of the neutron stars will actually rip stardust off of the neighboring star onto the neutron star's surface. And when that happens, you can get a mountain grow. So what happens is, as the neutron star rotates, that mountain hooks onto space-time and it stirs it up, which generates these gravitational waves. And so that's kind of what my project was about. It was more about how these neutron stars can grow these mountains. And the long story short is you need hotspots. So I was looking at how hot a hotspot can be, because the hotter the hotspot, the bigger the mountain.
So that was it quite theoretical based then?
Yeah, it was completely theoretical. So yeah, I used a computer to code it all up in, because they're just like fancy calculators. So this is why one of the really great things about physics is it doesn't matter where you are in the universe, the laws of physics are the same. But we can't visit a neutron star and we can't create the conditions of a neutron star in a lab. So what we can do is take our understanding of physics, put it into a computer and get it to solve equations, and that will tell us what could be happening or should be happening on the neutron star. So that's how I did it, yeah, through computers.
So you did your PhD, and what have you moved on to doing?
So I've recently taken up a job at the University of Bath in the physics department as an Ogden Outreach Fellow. So the Ogden Trust is a charity, and they work to try and get more people involved in physics. And it's part-time, and for me it's perfect. It's exactly what I want to do. Essentially, I'm bridging the gap between university and schools, and I want to work with school students who are less likely to go to university, who may not consider university as an option for them. And that can be for many different reasons, such as no one in the family's been to university before, or they might be living in quite rural countryside and don't really think of it. Many reasons they may not think it's an option for them. So I want to work with them to show them it is an option for them. And it's something I'm really passionate about, because I was the first person in my family to go to university. I didn't know any scientists, I didn't know any physicists. The only thing I knew about physicists was it was a job option on the Game of Life, and I remember being like, what's that? Just like a board game. I don't know if it's even about anymore.
Literally, I've got it up there, the Game of Life board game, but I didn't know physicist was an option in it.
Yeah, because I was like, wow, they had a lot of money in that game. They don't in real life. That's the biggest lie ever. So yeah, so that's something I'm really passionate about. But also, I'm really passionate in just making science, particularly physics, as accessible to everybody, as many people as possible. And which is why I started my YouTube channel and my Instagram. And so the rest of the time I actually spend communicating physics as a freelancer. So I'm going to pick up my YouTube channel. I'm working on that. I'm recording a new series. And I'm branching out to other social media networks. I'm dabbling a bit on Twitter, and I'm trying on TikTok, which is a bit of trial and error at the moment. And yeah, but I give a lot of talks in real life. I visit a lot of schools, and I deliver talks at festivals. I like to, because I'm trying to reach people that wouldn't usually think about having science in their life, or science is for them. I go to the places and put science in places where they probably wouldn't expect to see it. So you might see me in your city centre and coming up to you and being like, oh, have a feel of this. If I'm doing a bit of science busking, or I'll go to a music festival. Last year I was at Boomtown Fair. So some music festivals have science stages, others don't. Boomtown does not. So I was like, perfect, it's quite a party festival, it's not where you'd expect science. So I went there and gave a talk about time travel, and that was really fun. So I'm always trying to explore the boundaries of how I can do something new with it. And that's what I like to do with the rest of the time of my week, and hopefully make a living on it.
People actually, so when you're at Boomtown Festival, were people actually were they into the thought of actually going and seeing some physics?
Yeah, actually, so I had a time slot, and I was waiting to go on because there's people before me on the speakers tent, and yeah, people actually started turning up. They'd come and seen it advertised in the program and come to my talk, which was like a really incredible feeling. And it was a lot of young women that came, which is really important because women are significantly underrepresented in physics. So yeah, it was really nice to see that the people I want to reach were actually turning up for my talk. So yeah, it was really exciting, and it's one of my favourite festivals. So it was kind of like a really nice marriage of the two things.
That's the dream. What would you say then? So you've spoken a lot about physics. You do a lot of physics, like communicating. What if someone said, I want to do physics or a science, but they didn't like maths?
So do you not like maths, or is it that you're struggling with maths, or do you find it difficult, or?
So I'm gonna play the person now. See, this is based upon like experience. A lot of people want to do it, but they don't appreciate that maths is important. They'll be like, well, what's the point of doing maths as well? I'd rather just learn more science. So
yeah, okay.
They just said, I don't see the point of it.
Yeah, so okay, cool. So there is a huge point. They're not exclusive to each other. You can't have science without maths. It's like all the different sciences build on each other. So you have maths, which is like this pure, can be at times very abstract, and physics is like applying maths. And I think a lot of the issue with that is partly because of the education system that we have, like in the UK, and that is physics or science is taught as one subject and maths is taught as another, and it's not until you get to university that the two are actually combined. And it's very common for like British students to really struggle to connect the science and the maths together, whereas students that have come from other parts of Europe or further afield internationally, because they have a different education system, they don't seem to have that barrier. But you need the maths. So for me, maths is the language of the universe, and it's the universal language, and I think that's pretty an incredible thing. So you can think of all the different languages that are spoken on this planet. 20 miles up the road, I'd be in Wales, people speak a different language. I can walk there and it will be a different language. But if I was to travel to a different planet on the other side of the universe, and there were people, aliens that have language, they would also most likely know maths. And that's what's incredible about it. So if you want to understand, physics is understanding how the universe works. And if you want to understand how the universe works, you need to talk its language, and its language is mathematics. You want to see how something changes in time, like take speed or velocity. That's how the distance you move changes over time, and that's how you get speed. Like, you have to have maths in it. So there is a point. Absolutely, it's like a fundamental point. It's just, I think the way that we're taught it perhaps doesn't make that clear. But if there's a really cool thing you can do, you can just take an equation and it shows you everything. Like, I'm going to do it now. So, hang on, let me just see. Right, I'm just checking you can see this okay.
No, we're all good.
E equals mc squared is a really famous equation. Loads of people have heard of it, but hardly anyone knows what this means. And it is that energy is equal to mass times the speed of light squared. And so what that tells us is that the faster you move, because you gain kinetic energy, the heavier you become. It means if you charge up your mobile phone, you put in more energy, it's chemical energy it's stored, it becomes heavier. And it also means that mass contains a lot of energy. And the way that you can convert between the two, the energy and the mass, is through this number, c squared, the speed of light squared. And that's kind of like a currency exchange. If you want to change from pounds to euros, you need to know the exchange rate. Well, for energy and mass, the exchange rate is this number, the speed of light squared. So already it's such a simple mathematical expression, but it contains a lot of information, and you can't understand the information without understanding the maths. So that's why it's important, and that's why it's relevant, in my opinion.
And what is that number, the speed of light? What is that?
It's about 3 times 10 to the 8 meters per second. So if you square it, that's 9 times 10 to the 16 meters squared per second squared. So it's a huge number.
And so that's why when I charge my phone, I'm not suddenly struggling to pick it up. It's because that's such a high number.
Yeah, so it's a really small amount. So if you want to know, say you put in like 1 joule of energy, you're going to have 1 divided by 9 with 16 zeros underneath it, which is an absolutely tiny amount. So it's like a tiny amount. So that's why you can't tell the difference. But on the flip side, if you have 1 kilogram of mass, which is probably like a couple of phones. So if you had like 2 phones and you converted that into pure energy, because you're going to get c squared times a kilo, well, that's actually enough energy to power the United Kingdom for a year in just 2 phones worth of heaviness. So yeah, it works both ways. If you charge your phone, you can still pick it up because it's small, but your phone as mass, if it was transferred into pure energy, now I don't know what that looks like and you get losses, it's not that great, we can't do it yet, you'd get a huge amount of energy. But that's what kind of led the quest for nuclear energy, because we know there's a lot of energy stored in mass, but extracting it, that's the hard part.
I was going to mention what you had on the board beforehand, and it's all gone.
Oh, I've just rubbed it out.
I know. I'm just like, oh no, where do I go from here? But this is the usual thing that people say. That on the board was mathematics, wasn't it?
Yes.
There was no numbers.
No, there wasn't. They're all symbols, because the numbers are like the last bit you have to put in. Like, that's kind of the cool thing about maths. So really it's a lot of algebra, which I love. I love algebra. What a geek. But each symbol contains information, just like with d = mc squared.
Yeah.
C is a number, but if I was to write out 3 with 8 zeros, so 300 million every time, it's big, it's messy, it's easier just to make it 1 symbol. So maths is difficult, maths is tricky to get a grip of, and it's a hell of a lot harder if you've got loads of big numbers. If you just reduce it to a symbol, then that makes it a lot easier, and then you just plug your numbers in at the end. So it's making it easier for ourselves, really.
I'll edit back to that bit in the when I edit it. But what actually was it that was on the board? The perturbs model.
Oh yeah. So on the board was actually the equations that I used to put in the computer for my PhD.
No.
Yeah. So I've got my thesis here. Came prepared. So small disclosure, this is the penultimate version of my thesis. I haven't printed out the final version. So this is an idea of like how much of a thesis is. It's the book, it's about 150 pages. And there's equations on the side that are off the screen at the moment. And that's for my background model. So essentially I had to just build a normal neutron star before I had to put the mountain on. And for me to build that neutron star, it took me up to, here we go, 85. So 85 pages before could I get this really small little equation out. And I'll hold it up to the camera so you can see the equations. Here we go. It was page 83. Sorry, I got it slightly wrong. And it's these 2 bottom equations. Is that coming up?
Yeah, we've got that. Yeah.
Yeah. So yeah, those 2 equations have to be solved at the same time, and they contain 83 pages worth of information. And then to build the mountain on top, that comes another 20 pages later. And that's what I've got on this side before I rubbed it out. And I can show you those equations. These are a bit longer, definitely. So instead of F, I've got a symbol U because it's showing that there's a change that's happened. So that's one equation. And then we've got the temperature there, which is that equation. So yeah, that took 103, 104 pages of work. And really it took me 3 years to get that far.
How good does it feel to have that finally done?
It feels amazing, but it also feels really strange. It kind of feels like it's not over. I was expecting this like after, so you have a verbal exam, you write the book, you submit it, then you get examined on your thesis. verbally, and I thought I'd come out of there and be elated and be like, yeah, woohoo, it's done. And I was just like, okay. It doesn't feel real, it doesn't feel over, it feels a little bit like I don't deserve it, which is a really weird thing because I know I do, and I don't think I'm alone with this. It takes a while to like get back to your normal self, your normality after doing that, because I did spend a year without seeing friends and just working, and there's other stresses that come in and stuff. Yeah, because like in the UK you get funding for 3.5 years, but your PhD lasts 4 years. Yeah, there's lots of different aspects, and of course, you know, you have life that goes on, and it all adds up. So it feels a bit weird, and I think when you've been doing something so intense for so long, I'm not surprised it's weird. Yeah, but now I'm on the other side of it. It's really nice, and I'm just not forcing myself to do anything and taking a bit of time out for the first time in like 10 years, because that's how long I've been at uni for.
Including your undergraduate?
Yeah, including my undergraduate.
A long time. Do you ever like wonder what you would have done instead?
Yes and no. So there was no option. This was always what I was going to do. So I didn't know it as clear cut as this. So it was, I remember the moment I decided that physics was what I wanted to do. I was about 14 and I was in class in physics lesson, and we were talking about the universe expanding. And they just discovered that the universe isn't just expanding, it's accelerating as it expands. And I was like, whoa, right, expanding, okay, fine. Accelerating, I don't get that, like, no. And we were talking about it and all of this, and I was just like, I really want to know why, and nobody knew why. And today, quite a while afterwards, we still don't know why, but we have a name for it, and we call it dark energy. And I just thought, that's what I really want to do. I want to know. And I was like, yeah, I want to do physics. And actually my story's like non-conventional. I didn't do that well during my GCSEs. I didn't do as well during my A-levels. I had a lot going on in my life, so my schoolwork kind of dropped off. And I didn't do A-level physics. A-level maths I didn't do, but A-level physics I did do. But I didn't get the grades that would be good enough to go into university, and mostly you needed maths to study physics at university, as you pointed out. And I was one of those students who was like, why do I need maths as well as physics? I can do the physics. But the reality is you need both to get a good enough understanding to carry you through, and you need the maths A-level to prepare you, because at uni, things move quickly and it's easy to get left behind, so I have to work. So what I did was actually after my A-levels is I worked full time, I got a job, I worked in car insurance, and then worked in ad sales, but I'd found out that you can do something called a foundation year. And this is for people if you don't have the entry requirements for university. So I didn't have the maths A-level. It's 1 year. If you complete that year and you pass it, then you can go on to study physics at undergraduate level. And that's what I did. That's one of the reasons why I chose the University of York, because they offer the foundation year. And that was it. It changed my life. But beforehand, I did wonder maybe I should do fashion at uni. And I was a bit stuck. I didn't know what I wanted to do because I really enjoy creating. But I figured I could create as a hobby, but there was no way on earth I'd be able to do physics as a hobby. I need that support from one-to-one tuition. So then I was like, well, I'll just do that. And then that's kind of how it happened. So that was a really long-winded answer.
No, that's really nice. I didn't actually know that that's why you went to uni a bit later.
Yeah.
Because I remember you once saying that you had a gap between college and uni. I didn't know that was why.
Yeah, it was like 4 or 5 years. Yeah, I was 23 when I started my my foundation years. And then, because of course, the thing is, because I was actually wanting to do A-level maths, but my teacher said it probably wasn't a good idea because I was struggling, and it wasn't them being like prejudiced or anything. I do agree with them. That was the right decision at the time. I would not have been able to keep my head above water with it. But that still kind of knocked my confidence. It made me think that maybe I wasn't able. But then I started doing the foundation year. I had stability in my life again. I had the space to focus, and I did really well. And I did so well that I could actually subscribe to the master's course at York. So that's what I did. So then I just signed up to 5 years of my life at the university. And then during that, I had no plans what I wanted to do after the degree. I always just wanted to become a physicist, probably an astrophysicist. But as I went through, I found out that I actually loved the maths, and I wanted to do the maths with physics side. So that's why I went into theoretical physics. So I kind of started on this journey without the maths qualification. And actually my PhD wasn't in physics, it was in maths. So I was kind of like, it's amazing how things can change. And I didn't know that of myself. If you'd have told me then, I'd have been like, I don't believe you. But you got to try these things to find out, I guess.
Definitely. So if you've used mathematics then, everything that you've learned, it's all built up to doing this thesis. But what would you say to someone, maybe they're like 14 years old and they don't understand why they're learning maths? They'll be like, I'm never going to use it. Is that true?
You use it all the time. You use it all the time, even if you don't think. See, I remember I used to think that. I was a proper grumpy teenager. Oh, why am I doing Pythagoras theorem? Like, you do it. If you go to cross the road, you're looking at a car coming towards you. You've got to judge whether you can get across that road without getting hit by the car. You're actually doing the maths in your head to be able to do that. Not directly, you don't have to sit there and write out the equations, but to be able to make that judgment, you have to have an understanding of maths. Even if you don't want to do something academic, if you want to use your hands, if you want to be an artist or work in trades, you need to be able to measure and cut and make stuff fit, whether you're tiling a roof or whatever you're creating. And then if you go into like an academic route, then you still need maths, because like you need it in science. There's no way you don't. Even like as an adult, you'll have a house, you're gonna want to decorate it. You need to measure stuff. You need to understand the scale of what you're doing. So really, you need maths at every step of your life. So even though you may not directly understand where it's coming from when you're learning it at school, it's preparing you the skills of logic and understanding to help you through life.
Definitely, that's a perfect answer. Really nice. Really nice. I'm just going to mention, just for the sake of anyone watching, that you did a foundation year degree in physics. There's foundation degrees in lots of subjects, isn't there?
Yeah, so the one that I did, it was it's essentially GCSE maths and physics and a bit of A-level maths and physics all crammed into 1 year. So I was with engineers on that course. It was a mixture. And some people went on to do electrical engineering and physics engineering, but you can do foundation years in anything. There's foundation years in art. So the moral of that story is, if you want to do it, you're never too old. Because I hear a lot of people say, oh, I'd love to do it, but it's too late. No, it isn't. No. And you can do it, like, I'm not saying you wouldn't have to adjust your life, but yeah, and the Open University is a really great way to get into something if you wanted to dabble.
Have you ever done anything with the OU?
Yeah, I did. I tried to do a maths A-level. But the reality was I wasn't ready to pick up education at that time. I think I was probably about 19, 20, but I wasn't ready. Like, yeah, I just wasn't ready. Too much was going on.
That's a really good like little moral. If we finish on that, just like, if you're not ready, that's fine. Just take the time and come back to it if you want to.
Yeah, there's no rush with this kind of stuff. Like, there was even a person doing their PhD, and they're in their 50s when I was at Southampton, so that's where I did my PhD, you know, and like, I actually randomly met a physicist the other day, and he said he started his undergraduate when he was 36. So, yeah, if you're not ready, it doesn't matter. There'll be a time when you feel that you are ready, and that's the time to do it. I think there's a lot of pressure for us to go through school, get the good exams, go to university, and before you know it, you haven't had a chance to breathe. And where I took the time out, that gave me the chance to breathe, because if I went straight from my A-levels, I would have failed. Absolutely guaranteed. I'd probably have failed after my first year and dropped out, and then never would have tried university again. But I took my time, waited till I was ready, and then I got further than I could have ever dreamt of.
That's brilliant. That's really cool. Really cool. I think it's important to just acknowledge that people should try first time, but not fret if they don't get it first time, essentially.
Absolutely.
Yeah.
Yeah, practice, isn't it?
Definitely. I think that would be a perfect place to stop if you're all good with that.
Yeah, fine by me.
Nice one. Thank you, Emma, so much for your time.
You're welcome. Thanks for having me. But I like your hair like that. I think it's cool. Very teachery.
Right.
Cool. Okay. Take care. Lovely chatting.
Bye.
Bye.
Alright then, thank you. What's my hand doing? Alright, thank you to Emma for taking part in this. It was an amazing chat to have. That's it for our 2 researcher profiles. They made me really nervous because I've not done an interview for years and years since I was at the Royal Society, but both Emma and Rob made it so enjoyable on my behalf, and I hope it comes across and it was enjoyable and useful to those of you who watched it. So a big thank you to Emma and Rob, and big thank you to anyone who watched this, because that's what makes this worthwhile, isn't it? So check out these people on the Twitters and the Instagrams, and let's see what else we have in store. Alright, take care. I think I'll turn it off now.